even wherever you are, why don't we just stop here and we'll go over some of this together. So we'll finish it up.
Yeah, so that is like...
So we can get on to our other concepts here. It's a little, so I'll tell you, this is not the most efficient way to do this, but we did this as a demonstration of how this for loop worked and how these if-then statements worked. If you made it to the end, you'll realize it was kind of slow. Let's see, so first of all, are there any questions to start with? Questions about anything specific? Okay. Great, so here, I'll make you dizzy, let's scroll down here. So the first new thing we learned here was about this .ix function. This makes indexing a little easier. If you think about the homeworks that we've done, or the things we did in class before, we use brackets and we sort of grab columns by their names. Sometimes you could grab rows with these, but when you use this .ix function, or a method of indexing gets a lot easier. So basically you have on the left side here in the brackets, you have whatever rows you want. It could be a single number, like this. Let's try, row 1. Remember the rows start at 0, so this is actually the second row. And column 5 gives you your data value there. And if you want to range, you can use the colon, which gives you the slice. Called the slice function. And that's an easy way to grab rows and columns. Any questions about that? So you had some practice with that in there. It should make it a lot easier. So we practiced doing the subtraction using this, so you don't necessarily, as you can see here, in this part, let's see, I'll zoom in so it's a little more legible. You can call your columns by name, not necessarily by number. You could do either one. Okay? Great. How about this statement here for creating a blank column? Does that make sense? Does everybody understand why we did that? You wanted to create a blank column. So basically, part of the issue is you can't create a column one cell at a time on your data frame. You can't just add, the data frames are like a table. They have to be equal numbers of columns for every row as you go. So you can't start with row 1, calculate a new 3' UTR data point value, and then tack that on and sort of have an extra column for one row but not the others. We need to create the entire column at once. So this is what this does. It gives us a blank column. Okay, here's the next concept. We started using a for loop in a new way. So before, if you recall, so we had a for loop where you grabbed your item, sometimes we call the variable item, from data, from a list of data, and so it pulled each data point out of your list, and then you did something with that data point. In this case, we're using the for loop as kind of an index. It's just counting. It's counting from 0 to 100 in this case. And so this I is an index value that's very useful. You can plug it into to find the row that you should be on for your data frame. The range function just basically gives you a list of these numbers from 0 to 100. Any questions about this syntax? Does that make sense? All right, so here's the challenge. Is to actually recalculate the 3' UTR value. So here's how the code worked. And if you want, if you're close to it, if you're close to the end, you can, should be able to read that. You could type this in and start running the code. It may take a little while to work. So here's what we did. We added our column. You just took that statement right from above. And now here we have our various parts. We have our for statement. So we're going to use that principle for I in range. So the I is going to go from 0 to, and we want it to go up to the number of rows in the data frame. But we have to remember that we start counting at 0. So we use this little statement here. Everybody remembers what the len function does? It calculates the length of your data frame, the number of rows here, right? But we subtract 1 because we start counting at 0. So now we can, yeah.
Is the
The final number in the range statement does not get included. Like earlier, your range 0 to 100 stopped at 99.
Oh, you know what? That's a good question.
Yeah, you may not need the
maybe
Yeah, you don't need that minus.
You don't need that -1. Okay. This is the old Perl programmer doing things Perl way. There you go. Thanks. All right. Good to keep in mind, right? So let's go back up here. Yeah. See, I should have noticed. In our range statement, we went from 0 to 99. There. Okay. So you don't need that -1. Great. Okay. Now we're using our indexing. Again, we use I to tell us the row number that we're on. And we have our if statement. If, right, the data value in this row I in the strand column is equal to the plus, then you perform your subtraction. And if it's equal to the elif, that means else if, obviously, then you have your minus. Then you perform your subtraction for the minus strands. Any questions about this syntax here before I talk about the print statements I added in there? Does this make sense? Yeah, raise your hand if this is clear. Raise your hand if it's confusing. Anybody? Is there a question about any of this syntax? All right, great. So you can copy it down, you'll have it, and I'll send out the answers for this in-class thing, so if you want to think back on it, you have all the pieces you need. Now, this is rather inefficient. It takes a little while to run, as you may have noticed if you've already hit return sometimes, and even if things are not particularly inefficient, but as a way to check your data when you're performing calculations on large data sets, there are two things you could do. You know, for example, we could start out, so it doesn't run so long, we could start out with just a shorter range, right? We don't want to wait all those minutes for it to go through the entire data frame. We start out with a shorter range, see what the results are. Other thing we do to make sure everything is working properly, you can do is you can add print statements to just see where you're at. So here I added a print I statement. I just want to see what row we're at as we progress through the loop. This is not particularly necessary, but when I was taking so long, I was worried about where it was at. You could add print finished when it's done. That way, when you hit this shift enter on the cell, instead of seeing nothing and not knowing if it's working or not, you actually get this output in real time. So this is showing me all the I values. You could print whatever you want. You could print the values of the new UTRs you calculated to make sure each is working. You could put a print statement in both parts of your conditional statements. So I only have it here. So I assume if it progresses on to the other ones, then it's also, you know, successfully moving through the minus strain ones. Oops. And anyway, it's at the end it says finished. So make your code verbose. If you're going to calculate on a lot of data, you want to add print statements to see what's going on. So there's a tip. All right, and I'll let you read the last part here about getting rid of on your own, about getting rid of that extra column. All right, so that's the end of activity 1. Any questions at this point? Again, I'll put up this worksheet with all the answers so you can go over it. All right, let's see. Where are we at? All right, we'll do this next section, which is not quite so long as this one, and then we'll take a break here. All right, so let's talk about the confusing proliferation of parentheses, brackets, and in some of your homeworks, you've even seen curly braces here. What do they all mean? When do you use them? So you've been using them in indexing. We've made various statements, but you've made some complicated indexing statements in some of your activities and homeworks. But in order to really understand the logic of how those brackets work, we really need to understand what kinds of variables are going into the code we're writing. So here's an example of how you use parentheses. Right? We know we can use parentheses in math, in Python, right? You put your parentheses to make sure that if you forget the order of operations, to make sure you're getting what you want. Here's you can also use them, this is kind of like the math usage, you have logical operators and comparison operators. This is taken from homework 3. You can see you have multiple parentheses in here to separate, there's a conditional, an equals, a comparison statement, there's an or statement, so you're going to break all these little bits into parts using parentheses. This is from homework 3, this should be familiar here. So parentheses are used there just like in math to break things into parts. And finally, another thing you've seen is parentheses are used in functions, right? You have a function and the parentheses, and sometimes inside of that function you put what are the arguments to the function. All right. Now, let's talk about brackets and curly braces. So to understand this, here's a key concept. Complex data types in Python and other programming languages are constructed from simple ones. So we've been working with a data frame, which is an object or a data type in Pandas. It's actually constructed from simpler objects, and so if you understand a little bit about what those objects are, the parentheses, the brackets will make more sense. So here we go. So let's look at some of these. Objects. They're a little simpler than what you've looked at, and they with brackets. So in the first lecture, we talked about some simple variables. We talked about integers. We talked about floating point numbers, numbers with decimals. We talked about strings that have characters in them, or they could have numbers too, but the numbers are treated as a text character because they're in parentheses. These are a little more complicated than those basic types. These are lists. So a list in Python is basically a series of values. They can be integers, they can be characters. They're enclosed in brackets and separated by commas. So these are integers. Here's a list of strings. And notice they're set out in parentheses. It tells you it's a string. I'm sorry, not parentheses, single quotes. A list can even be mixed. Right, so this is a list of part of my address here. You can have a number, you can have a character, you can have something like that. So lists aren't always mixed, but they can be. So that's where brackets come in sometimes. So if you see brackets, one of the first things you may want to ask yourself is this a list? And as you can see, there's some giveaways. They have commas there, but a list, you can have a list of one item too, so it won't necessarily have a comma. All right. Lists can be nested, and so then the brackets start adding up. So let's take a look here. We're making a list of numbers, 1, 0, 1, 2, 3. We're making a list of letters, A, B, C, D. Now we're going to make a list of those two lists. And I'm not doing this in the notebook right now, but if you wanted to try it, you would probably see these double brackets, right? So there's a list of two smaller lists and separated by a comma. So brackets can quickly get complicated. Another use of brackets, as you've seen, is in indexing. So, as we've seen here, we've already used this a lot. You use your column name and you put it between brackets. As far as I know, and if anybody's more familiar with Python, correct me, this is different from a list. This is not an implementation of a list here. We can put lists in those brackets if you want to select multiple things, but this is different. This is indexing. And you can even index string variables. So for example, we're going to assign the string Python to the variable w, and you could type this in there, w, and index it with a 0, and it will pull out the first letter for you, right? And you could add, so it works like that. So you've also seen what we call in Python slicing. That also goes between brackets. You get a range of numbers. In your case, it's 0 up to, but not including 5. Kind of like that range argument. So don't get tripped up by that, like I did. So here, for example, we're going to use the slice to pull out part of Python. If you assign Python to W and you go 0 through 3, you're going to grab the first 3 characters, 0, 1, and 2, from Python, and we'll give you that output. You can try that in a notebook if you want. Okay, so that's sort of the basic types of brackets. It's not everything about brackets, but those are the most common things that you're going to see. You also see curly braces sometimes, and there are other types of data, types of variables or objects that involve curly braces. So there's a type called sets. They're like lists, but they're not ordered. A list, you can index. Things come in an order. There's object 0, 1, 2, 3, and so on. Curly braces is basically an unordered list. So there's really no intrinsic order to your 4 nucleotides here. I suppose you could make it in alphabetical order. But so you put these in curly braces, and it looks like a list, except it's in curly braces. So what would be the implications for indexing here? And what can't you do now with sets? You can't use that bracket notation. If you wanted to grab guanine out of that, you couldn't type nucleotides bracket 2 in that case, 0, 1, 2, because it doesn't work in a set. It's an unordered group of values. And then finally, now this is a really important data type, used a lot, and it gets incorporated into data frames sometimes. They're called dictionaries. This is also an unordered group. But, you know, unlike sets, we're not quite so hopeless without the ordering. What we have are key value pairs. And you saw this in homework 3. So you can assign a variable to something within these curly braces. You write the key, that's essentially the label, the name of this set of objects or object, and then you have a value. And the value can be a number. The value can actually be a list. And so each of these key value pairs are set apart by a comma and then entered by curly braces. So here's an example. If you wanted to put the genetic code as a dictionary, you would have the abbreviation of your amino acid as your key, and then you have a list of the codons here. This is right. Here we see our brackets. It's a list, and those are your values. So how would you look up a value in this case? By the key, by the label. And we'll look at that a little later. Let's see. Any questions so far? Great. All right. Great. So now let's move on to activity 2 here. We're going to look at, so this should be, oops, here we go, a little briefer than the other activity here, but you're going to get some practice now with these data types. So, and let's start some of this together. So we're going to use basically this type function, which we used a little bit in the first computational class, to see if we can identify sets, dictionaries, whatever, as we come out of this. So, but what we really want to know is what are the pieces of our data frame? When we pull something out of our data frame, let's think about it this way. When you pull out an entire row and assign it to a variable, when you pull out an entire column and assign it to a variable, what is that? What kind of data point is it? How is it indexed? And what can you do? What can you do with it? And you'll see it's actually a data type that it'll be a little surprising. All right, so I just want to give you an example here. Let's take a row, variable r. You can type along with me here. And let's see, we're going to use our data indexing function, right? And let's take the first row. We'll start with 0. So we do that, right? And now let's look at the type. Let's figure out what it is. R. So this is a practice you should do as you're trying to write your code and you're working with complex data frame, objects like data frames, to figure out exactly what you have and how you can index it and what things you can pull out of it. You can use the type function. Oops. Oh, you know what? This is a blank notebook here, so I haven't pulled it all in here. Let's try this. Let's try 0. Here's what I've done. We're on activity 2. We try row 0. Let's just take a look at the variable. Let's type in R and see what you get. And you can see the output. You can see actually you get your entire row. Here are all your columns, the column names, and the values. And so what's the type of R? Let's try this. Type R. And it tells us, this is as part of the Panda, an object in Pandas, it's something called a series. So here's another data type that is, it's kind of like a list, but it's kind of like a dictionary, but it's a little different from both. Basically, it's a one-column table. So remember, a list was just a series of numbers. Remember, a dictionary was an unordered set of some key and value pairs. Basically, here we have a list of values, and each of the values gets a label. But they do go in order. So try this. Let's move on to the next one. Let's pick out the value of R0, right? If you type that, you get the gene name. Let's try item 4. You pull that out and you get whatever that is here. This is the transcript N. So it's indexable. But it's a one-dimensional object, essentially. What if we tried to do something like this, pretending to have rows and columns? I don't even know what's coming out. It works. Try things. I'm not sure. It must be ignoring that. But you don't really need that. Okay. So, okay, we pulled out one type called a data series. It's indexable. All right. Let's move on to the next one here. Where do we go? More indexing. All right. So from here on, I want you to move on yourself here. We'll do this activity. You can move on to the next one. Do essentially the same exercise with a column now. And then single values. And we're going to move on and look at how you build a data frame from a dictionary. But you can do this with the notebook.